baryons. Okay, so you have baryons. Then charge noted by capital Q. Then you have I3. Then baryon number. Then strange number. Finally, quark content. Okay, so first will be proton. Okay, so charge is +1, right?
Yes.
I3 is half. Baryon number is 1. What about strange number? S number
0.
is very good.
0.
Very good. So yesterday I shared that story that most of the mesons and baryons are made up of 3 quarks basically, up, down, and strange. So for proton, S is blocked because S number is 0. So obviously it will be made up of up and down, right? Right? Is not it?
Yes, sir.
So can you please tell me that content?
Up, up, down.
Very good. Everybody agreed? Everybody agreed?
Yes, sir.
Everybody? Any doubt? So it is up, up, down, right? You can check also. Let us check charge. So for proton, charge is +1. Up has charge +2/3. So +2/3 +2/3, 4/3. For down, it is -1/3. So 4/3 -1/3 is +1. I3 for up is +half. So +half on, then -half for down. So I3 resultant I3 is half. Baryon number for all 1/3. So it will be on. There is no strange quark. So obviously it will be 0. Right? So everybody agreed?
Yes, sir.
Very good. Now we'll check for neutron. So it has charge 0 since it is neutral. I3 is -half, right? Baryon number is on. S is 0. Now can you please tell me that quark content?
Up, down, down.
Up, down, down, right?
Yes,
Everybody agreed? So it will be up, down,
Yes,
down.
sir.
You can check also. Next is lambda 0. Charge is 0. I3 is how much?
0.
Zero.
Very good. It will be 0. Baryon number is on. S number is -1.
-1.
Right? Very sorry, -1. Extremely sorry. It is -1. Can you please check now? So S is -1. So definitely there will be on S, right?
UDS bar.
UDS bar? No. S for S. Yesterday we have derived S is
UDS.
very good. Everybody agreed? Everybody agreed?
Yes, sir.
Okay.
Yes, sir.
It will be UDS, right? It will not be S bar because S has that S quantum number is -1. If it is +1, then it will be S bar.
Yes, yes.
Also, you can check other quantum numbers also. It will satisfy. Okay. Now sigma plus. आप लोग बताइए जरा चार्ज तो इसका कितना है? ऑन है.
+1.
I3 +1 है. B
+1.
is on है. S -1.
Yes, sir.
हाँ बताइए जरा इसका कितना होंगे? क्या कंटेंट होंगे? आप बताइए.
UUS.
Sir, up strange.
Up strange. Very good. Everybody agreed?
Yes, sir.
हाँ. S -1 तो डेफिनेटली एक S होंगे. अब चार्ज +1 है ना? तो डेफिनेटली 2U होना चाहिए. तभी तो आपका चार्ज कितना आएंगे? ऑन है. सॉरी ऑन आएंगे क्योंकि S का चार्ज -1/3 है. So definitely there will be 2U. So it will be UUS. Okay. Everybody
Yes, sir.
agreed? Okay. Now we have sigma 0. Charge is 0. I3 is 0. D is on. S is -1. So for content will be
UDS.
anybody?
UDS.
UDS?
UDS. Yes.
UDS, right? Now sigma minus, charge is -1, I3 is -1, D is on, S is -1. Now quark content will be
DDS.
DDS. Very good. Everybody agreed? Everybody agreed?
Yes, sir.
So it will be DDS. किसी को कोई डाउट हो तो बताइए. Is there any doubt in the class? Is there
No,
any
sir.
doubt? Okay, very good. Next is cascade 0. So it will have charge is 0. I3 is how much?
Plus of
1 by 2
Very good. Baryon number is on. S is how much?
minus 2
minus 2.
Very good. Then core content will be
USS.
USS, right? Everybody agreed? It will be USS.
Yes, you will.
So there will be definitely 2s because S number is -2, and since it is neutral, that's why you have to take U because net charge is 0, right? Now we have cascade minus, charge is minus on, I3 is minus half, B is on, S is -2. Then core content will be what?
DSS.
DSS. Everybody agreed? Everybody agreed? So it will be
Yes,
DSS,
sir.
right?
Yes,
Ah, very good. Very good.
DSS.
Sorry, extremely sorry. It will be DSS because S quantum number is -2. Extremely sorry for that. Okay. So it will be DSS. Next is omega minus, charge is -1, sorry. I3 is how much?
0.
Very good. B is 1. S is how much?
Minus 3.
Minus 3.
Very good. -3. So it will be simply SSS, right? है ना? क्योंकि 3 है. S quantum number -3 तो आपका 3 S होना चाहिए. Okay. Any more particle from baryon? Any more
No.
particle?
Heavy baryons.
Yes. Heavy baryon तो है ना? I think you are categorized it into different way, right? So heavy baryon is there. So first one is delta double plus, right? डिस्कस करें इसको, करते हैं ना, सबका देखते हैं. डेल्टा प्लस का चार्ज कितना है? +2 है ना? I3 कितना है? जरा बताइए I3 कितना है डेल्टा डबल प्लस का? एनीबॉडी?
3/2.
3 by 2.
2 by 2.
Very,
sir.
very
Yes, 3 by
Plus
Very
3.
good. It will be 3/2. Baryon number is how much? 1. S is how much? S is how
0.
much? Very good. It will be 0. So it will be simply U, right?
0.
So core content will be U because charge is +2 na. Okay. Next is
Yes, sir.
yes. So for delta double plus, core content will be U. Okay. Next is delta plus. Can you please me that charge? You tell me that charge. It will be +1. I3 is how much?
Plus 1 by 2.
Very good.
1/2.
Very good. It will be +1/2. B is how much? 1, right? S
One.
is 0, right? So core content will be
QUD.
UUD, right? Everybody agreed?
Sir,
Yes, sir.
Very good.
Yes, sir.
Very good. It will be UUD. Next is delta 0. Charge is 0. I3 is how much?
minus of
-1/2.
-1/2. B is 1. S is 0. Then core content will be
UDD.
very good. It will be UDD. Next is delta minus. Okay, charge is -1. I3 is -3/2. B is 1. S is 0. Can you please me that tell me that core content? Anybody?
triple D.
Everybody agreed?
DD.
Yes, sir.
Very good. Because I is -3/2. Sorry, I3 is -3/2, right? So it should be triple D. Okay. Next.
Must have touched it.
Yes. So next is sigma star plus. charge is +1, I3 is on, sorry, I3 is on, baryon number is on, strangeness is how much? Strangeness is how much?
Minus one.
Very
-2.
good. -1 because this is sigma particle.
Yes, yes, sir.
Core content will be. What about core content? Anybody?
UUS.
Very good. It will be UUS. Okay. Everybody agreed?
Sir.
Okay. Next is sigma star 0. Charge is 0. I3 is 0. B is on. S is -1. Then what about that core content?
UDS.
Very good. It will be UDS. Everybody agreed? किसी को कोई problem? Everybody agreed? I think
Yes,
आपको हाँ सबको समझ में आ रहा है. Next is sigma star -1. Sorry, minus. So charge is -1. I3 is -1. B is on. S is -1. Core content will be.
DDS.
Everybody agreed? DDS. Everybody?
Yes, sir.
Yes, sir.
Very good. So it should be DDS. Next, cascade star 0. Charge is 0. I3 is half. B is 1. What about S? What about S?
-2.
-2.
Very good. -2. Then what about that core content?
USS.
USS. Everybody?
Yes.
Okay. Very good. So it should be USS.
हटाइएगा.
Sorry. Next is cascade star -1. Charge is -1. I3 is -half. Baryon number is 1. S is -2. What about that core content?
DSS.
Very good. So it should be DSS. Next is omega star -1. Charge is -1. I3 is 0. B is on. S is -3. Then it should be SSS. Right?
Yes, sir.
Okay, very good. So another aspect of particle physics is meson octet, baryon octet, and baryon decouplet. So what does it mean? Meson octet mean few of the member from meson can be arranged in the form of octet. So the heading will be meson.
Hello, sir.
Yes.
Sir, baryons and heavy baryons don't take core content same here. Sir, एक heavy और एक नहीं.
Yes, yes. That's a very deep question. Very deep question. I appreciate it. You should have this kind of curiosity. You see, they have similar core content, but one is heavy and another is light, right? Because that heavy baryon, whatever they are produced, that heavy particle they are producing, they have very small lifetime, and they are always in excited state. And excited state means they have higher energy, and energy and mass are related. Okay, that's why they are heavy. That's a very deep question. I appreciate it. That's a very deep question. Who is this? Who asked this question?
Sir, it's Nishant.
A very deep question. Very deep question. I appreciate it. Both have similar core content, but they have different mass. One is heavy, and another is low, light. Okay, because of this, they have extremely small lifetime, and they are always in excited state. Excited state means they have higher energy, and energy and mass are related to each other. That's why they are heavy. Okay, very good. Very good. So meson spin 0 octet. Spin 0 octet. So, like periodic table, if you remember, why the periodic table is important, because you can easily understand the atoms are arranged in such a way they have some common property, right? Like transition metal, 3D transition metal, like 4D transition metal, inert gas, they are in similar group, right? Like that. So similarly, to understand that meson particle, they have arranged, scientists have arranged that particle. So few of the member will be arranged. So along y-axis, you have hypercharge. Hypercharge noted by Y, and it is equal to B plus S. And along x-axis, third component of isospin, that is I3. Okay. So suppose this is half, this is 1, this is minus half, this is minus 1. So K plus का I3 कितना है? How much?
Plus 1 by 2.
Very good. Plus 1 by 2, and it has stress quantum number is plus 1, right? So if you keep it in this graph, so it should be, suppose y is on here, so position of K plus should be somewhere here, right? Is not it? Everybody agreed? So I3, K plus has I3 value half, and its Y value will be, should be on, right? So it should be somewhere here. Everybody agreed? Is
Yes,
there
sir.
any doubt here? Very good. What about K0? What will be the position of K0? Anybody? So it should, I3 is minus here, minus 1, sorry, minus half, excuse me, sorry, minus half means along this side, and its S value is how much? Plus 1, right? So position of K0 should be somewhere here. Everybody agreed? Everybody
Yes, sir.
agreed? Okay. Now, what about pi plus? Pi plus should be here because it has Y value will be 0, because B is 0, S is 0, so pi plus should be here. Everybody agreed? Everybody agreed?
Yes, sir.
Very good.
Yes, sir.
What about pi 0? Pi 0 and eta 0 should be here. And pi minus should be here. Right? Not here. Should be on axis. It should be here. What about K minus? Where will be the K minus? Anybody? So K minus should be, if you take this is minus 1,
K0 का
नीचे. It should be somewhere here, and K0 bar should be somewhere here. K0 bar. Okay. So if you connect it, now you see this particle and this particle will have same charge. This particle will have same charge, and this particle will have same charge. This particle, these two particles will have same Y value, same S value. Okay. This particle pi plus, pi 0, eta 0, pi minus, this particle will have same Y value, S value, and this particle will have same Y value, S value. Okay. So there is a deeper understanding. So there is a relation. Okay. And
सर एक बार वापस से.
हाँ देखिए K plus और pi plus का चार्ज सेम है. They have same charge, right? K0 bar, sorry, this is K0, not K0, okay bar. K0, pi 0, eta 0 और K0 bar, इनका जो चार्ज है वो सेम है, और pi minus और K minus इनका चार्ज सेम है. So like a diagonal. And you see, if you take horizontal line K0 and K plus, it should have Y value same, S value same. Pi plus, pi 0, eta 0, pi minus, it should have Y value and S value same. Similarly, K0 bar and K minus should have Y value and S value same. And there are 8 members, if you check. That's why it's a octet. On to yes.
सर मैं मतलब
Sorry,
पर मुझे फिर से बॉर्डर
sorry, your voice is not clear. Anybody? Can you please tell me? Voice is not clear.
सर रिपीट करने को कह रहे हैं
Oh, okay, okay. ठीक है. So the topic was the few of the member from Mason family can be arranged in the form of octet. So if you take y-axis, along y-axis is y means hypercharge, and that will be b plus s. Along x-axis you will have I3. Then you can arrange that member. Suppose you have k plus has I3 is how much? Plus half, and its y value will be 1 because b is 0, s is plus 1. So k plus will be somewhere here if y is 1 here. Okay. Similarly, K0 के लिए I3 कितना है आपका minus half है, so it should be somewhere here, and its S value is plus 1, so it should be somewhere here. Now if you take pi mesons, so all will be along this axis, I3 axis, because it has Y value is 0. Because S is 0, so pi mesons and eta mesons will be along I3 axis. Now if you take K minus and antiparticle of K plus, it will be here because for antiparticle S will be -1 and I3 will also be negative. So K plus का antiparticle करोगे तो इसका I3 कितना होता है? प्लस हाफ होता है. तो K माइनस का क्या होंगे? माइनस हाफ होंगे, और K प्लस का S प्लस 1 होते हैं तो डेफिनेटली K माइनस का माइनस हाफ होंगे, सॉरी -1 होंगे. That's why it will be located here. Similarly, you can locate K0 bar also here. If you check, K0 bar should be here, somewhere here. So now if you check diagonally, so K plus and pi plus will have similar charge. K0, pi 0, eta 0, K0 bar will have similar charge. They are neutral actually, and pi minus K minus will have similar charge. Now if you check horizontally, K0 and K plus will have similar Y and S. Pi minus, pi 0, eta 0, and pi plus will have similar Y and S. Then K0 bar and K minus will have similar Y and S. So there are 8 members. Any problem?
सर
Yes.
सर ये जो ऑक्टेट है इसके अलावा ये जो y और चार्ज सेम है, इसके अलावा और कोई प्रॉपर्टी शो करते हैं लाइक पीरियोडिक टेबल में जब जैसा केमिकल प्रॉपर्टी सेम है, लाइक इसके जैसा और कोई प्रॉपर्टी ऑक्टेट?
Anybody? Alok? Anybody?
What, sir?
Is there any more property you can take from here? Whatever I told, any more property, you know? So
Core content.
yes. Core content, yes, definitely core content you can say. Every that origination of I3, these all are based on core content, right? You can tell core content also. You can write it. That's a very good point. Is not it? Core content also you can tell. Any more, Alok?
I don't know, sir.
Yeah. So I think this is the more understanding. Whatever I said, like core content on guy said, it's a good point. Core content, then similarity of charge, Y, S, everything you can infer from here. Okay. So in question, whatever question used to ask, suppose they will give like this, and they will miss this. So this particle should be what in question in CSIR or GATE. So this particle should be what they will ask, and you have to check. Okay. Or suppose here some particle is given, then its strangeness or something they can ask. Okay. Once they have asked, there was a missing of one particle, and they have asked which particle is this. Okay. So there is a deeper understanding, right? You can understand that philosophy whatever I shared, right? Did you get what I'm saying?
Yes, sir.
Okay, very good. I believe you people will do very good research. I believe you people have so much curiosity. Okay. Now we will have similar to meson octet, you will have baryon octet also. Baryons, spin half octet. अब आप लोग बताना है ना, फिल करना, मैं जस्ट पूछूंगा आप लोगों को. So it should be half here, then you will have on this side you will have half, minus half, then this should be minus 1. Okay, and this is y axis, this should be b plus s. Okay, and let us take this is plus 1, let us take this is minus 1. Now can you please tell me which particle will be here? Anybody?
Proton.
Any more? ठीक बोल रहा है? हाँ?
Yes, sir.
sir.
Yes, definitely he is correct. It should be proton. What about this point? So here I3 is minus half, y is
Neutron.
neutron, right?
No, sir. Yes, sir.
Very good. So it should be neutron. What about this point?
Sir is sigma 0.
Sigma 0?
Sigma 1 plus sigma plus.
Okay, very good. I understand you are trying to say sigma plus, right? I understand. Okay, everybody?
Yes, sir.
Everybody? Okay. So it should be sigma plus. This point should be origin
Sigma naught.
lambda 0, right?
Yes, sir.
Here it should be minus, right? Now what about here? Which particle will be? Suppose here you are taking. Anybody?
Cascade.
Cascade minus.
Minus.
Why cascade minus? Because this side you have I3 positive.
Cascade 0.
Everybody agreed? Everybody agreed?
Sir.
Very good.
Yes, sir. Cascade 0.
Very good. So it should be cascade 0. Okay. And this side it should be which
Cascade
particle?
minus.
Cascade minus. So are you enjoying class? Any problem?
Yes, sir.
Everybody? Any problem in the class?
No, sir.
Are you enjoying?
Yes, sir.
Yes, sir.
Very good. I have a dream that you people will do very good research. Okay. So
Thank you, sir.
yeah, most welcome. So now you can connect. Okay. आप देख सकते हैं इसका चार्ज this fellows should have similar charge. These diagonal fellows should have similar charge. These diagonal fellows should have similar charge. They have similar y. They have similar y. They have similar y. Okay. So in the question they may ask, they will give keep the question which particle is this. Okay, or any other place also. Okay. Another this kind of graph is there. Any guess? Anybody? 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 Alok?
Yes, sir.
Any this kind of arrangement is there? That name you know? Yesterday I was discussing last time.
Sir,
Can you
decoupled.
repeat your question, please?
So it is decouplet, right? Baryon decouplet. And spin is how much?
Yes, sir.
Spin is how much?
Right.
Spin is 3/2, right?
3/2.
Very good. So I'll draw this. किसी को क्लास में या कहीं पे प्रॉब्लम हो तो मेरा नंबर ले सकते हो, मेरे को कभी भी पूछ सकते हो, है ना? इवन रिसर्च में, बिकॉज आई एम वेरी क्यूरियस अबाउट रिसर्च, यू नो, यू कैन आस्क मी एनी टाइम, आई विल गाइड आल्सो. ओके, सो अलोंग y axis you have hypercharge. This is I3. Now divide it half on 3/2. This side minus half minus on minus 3/2. Sorry, should be minus 3/2. नाउ यहाँ पे बोलिए जरा, यहाँ पे कौन सा पार्टिकल होंगे ऑन के ऊपर, यहाँ पे या यहाँ पे नहीं होंगे. एनीबॉडी? 3/2 corresponding positive plus on y. Anybody? Sorry. Anybody?
Delta plus.
Everybody agreed? Whatever he is saying?
It's a delta double plus.
Delta double plus. Why delta double plus? Anybody?
Y
I3
y equal to 1 and
yes.
I3
I3 is 3 plus 3/2 and y will be plus 1 because S is 0 but B is plus 1. So it should be delta double plus. Now where will be the delta plus? Anybody? Where will the delta plus?
half. I3 equal to half.
Yeah, very good. So it should be corresponds to here. What about delta 0?
Minus of.
So it should be somewhere here, right? Everybody agreed? It should be delta 0. And here it will have delta minus, right? Okay, any problem? Now you have, what will be that point? Which particle will be here? Anybody? Which particle will be here? It will be sigma star plus 1, right? Sorry, sigma star plus, right?
Yes, sigma star plus.
Here you will have sigma star 0 and here you will have
Sigma star minus.
Sigma star minus, right? What about this point? Corresponds to, suppose this is minus 1, this is minus 2. So what about this point? It will be cascade star 0, right? Why I am taking star? Anybody? Why I am
Yes.
taking star?
Heavy.
Any more point?
So spin.
Unstable.
Sorry?
Spin.
Yeah, very good. That's very good. Because we are taking all spin 3/2, right? So it should be star. And this point will be corresponds to which particle? Star minus, right? Right. What about this point? Minus 2. What about minus 2? Any particle will be here?
Sir,
Oh.
we vary on cascade star 0 की straightness to -2, you know.
Yes, straightness is minus 2 and B is plus 1 because we have taken y-axis is hypercharge, right? So B plus S is minus 2 but B is plus 1. So it should be minus 1, right? Is not it? Everybody agreed or not?
Sir,
Whatever. Yes.
सर हाइपर चार्ज को 2 into एवरेज चार्ज भी लिख सकते हैं ना?
2 into average
Yes,
charge.
sir.
What about average charge?
मतलब ये जो कैस्केड है, कैस्केड का दो ग्रुप, दो पार्टिकल है, कैस्केड 0 एंड कैस्केड माइनस. तो 0 एंड -1, -1 एवरेज मींस -1/2 into 2 माने -1 means.
You are deriving the relation by yourself, right?
No sir, actually मैं इसको
Trying.
बीएससी में पढ़ा था, तो 2 into एवरेज चार्ज इक्वल टू हाइपर चार्ज.
हाँ, मैं भी कर सकता हूँ, बट यहाँ पे सिंपल है. y equals to b plus s, since it has s is -2 and b is +1, so 1 minus 2 will be -1. That's why it corresponds to -1, and it has I3 is plus up, so it should be somewhere here, and cascade minus should be somewhere here. And here -2 corresponds to which particle? Anybody?
ओमेगा
minus.
ओमेगा माइनस.
ओमेगा स्टार.
हाँ, ओमेगा माइनस भी लिख सकते हो. क्यों? क्योंकि इसका मास भी ये भी बहुत हेवी होता है. It is also heavy and it has spin is how much? Spin is how much?
3/2.
3/2.
3/2. Why it is heavy? Anybody? Why it is
Short.
heavy?
Short lifetime.
Short lifetime. Any more? So if you see inner structure, इसमें क्या है? S है ना?
Yes, sir.
Strange quark. Strange quark is heavier than up and down, right? And it has 3 strange quark, right?
Yes.
Yes.
So we can arrange like that. Okay. So डायगोनली देखोगे इसका चार्ज सेम है, इसका चार्ज सेम है, इसका चार्ज है, जैसे प्रॉपर्टी इसका बताया इसका भी आप कर सकते हो. ओके. So this is the arrangement. Now we'll go for Feynman diagram, but this is not related to CSIR. Okay. We'll understand for the sake of your research. Okay. So I'll give that some brief introductory about that Feynman diagram. Anybody aware of that Feynman diagram?
सर सुना तो है.
Anybody have done? Anybody?
No, sir.
सर बहुत बेसिक्स आइडिया बस.
Basics idea है तो at least. Okay, very good.
Yes.
So Feynman diagram basically pictorial representation of any interaction of subatomic particle. Okay, एक आपका क्या है, पिक्चोरियल रिप्रेजेंटेशन है. इसका कुछ रूल है वो मैं पहले बताऊंगा आपको. ठीक है. तो पहला रूल है कोई भी इंटरेक्शन को दो एक्सिस में आपका ये करते रिप्रेजेंट करते हैं. कोई भी इंटरेक्शन में दो एक्सिस लेता है और ये नहीं है कि इस साइड आपका टाइम होगा और इस साइड स्पेस होगा. और मैं जो मेरा डिस्कशन में क्या लूंगा, मैं हमेशा इस एक्सिस को टाइम मानूंगा और इस एक्सिस को क्या मानूंगा, स्पेस मानूंगा. तो कोई भी इंटरेक्शन को दो एक्सिस के थ्रू आप क्या कर सकते हो, उसको रिप्रेजेंट कर सकते हो. एक होंगे आपका टाइम एक्सिस, एक होंगे आपका स्पेस एक्सिस. बहुत सारे लोग क्या लेते हैं, दिस एक्सिस इज स्पेस टाइम एक्सिस, दिस एक्सिस इज space axis, but you can take any one. Okay, no problem. So any interaction can be represented in two axes. One will be time axis, another will be space axis. Okay. Second rule है, जब कोई पार्टिकल को हम डिफाइन करेंगे तो उसको देंगे सॉलिड लाइन. ओके, एंड दिस इज फॉर पार्टिकल एंड इट्स फॉरवर्ड फेसिंग. जब पार्टिकल को हम डिस्क्राइब करेंगे तो हम क्या लेंगे, सॉलिड लाइन. ओके, एंड इट शुड बी फॉरवर्ड फेसिंग. फॉरवर्ड फेसिंग मींस, व्हाट डज इट मीन फॉरवर्ड फेसिंग? एनीबॉडी? फॉरवर्ड फेसिंग मींस क्या है? एनीबॉडी, एनी आइडिया? फॉरवर्ड फेसिंग मींस इंक्रीजिंग टाइम. इंक्रीजिंग टाइम. फॉर एग्जाम्पल, सपोज मैं आपका इलेक्ट्रॉन को दिखाऊंगा, तो इलेक्ट्रॉन को मैं कैसे दिखाऊंगा, बिफोर इंटरेक्शन इट शुड बी लाइक दैट. सो यू सी विथ टाइम इट्स इवॉल्विंग, है ना. यारो चिन्ह देख के आपको पता चल रहा है ना, इट्स अ फॉरवर्ड फेसिंग बिकॉज विथ टाइम यू सी इट रिप्रेजेंटिंग सपोज समवेयर हियर इनिशियली. सो विथ टाइम इट्स इंक्रीजिंग. ओके, सो सॉलिड लाइन पार्टिकल के लिए हम यूज करेंगे और इट शुड बी फॉरवर्ड फेसिंग. फॉरवर्ड फेसिंग मीन्स इंक्रीजिंग टाइम. Now for antiparticle, it should be backward facing. This is for forward, for particle. Backward facing will be for antiparticle. For antiparticle. Sorry. तो यहाँ पे लिखता हूँ मैं. So for backward facing will be for antiparticle. It means decreasing with time. Okay. तो ये पार्टिकल का डिस्क्राइब के लिए हम क्या लेंगे, सॉलिड लाइन. ये याद रखना आप, जब मैं जाऊंगा तो फिर ये काम में. और जो इंटरमीडिएट पार्टिकल है इंटरमीडिएट पार्टिकल बोले तो एनीबॉडी? इंटरमीडिएट पार्टिकल
field particle जो भी
exchange particle, right? So for intermediate particle, इंटरमीडिएट में क्या क्या हो सकता है आपका? फोटोन हो सकते हैं. इंटरमीडिएट मीन्स एक्सचेंज पार्टिकल. ओके, तो इट में भी फोटोन. तो फोटोन को हम कैसे रिप्रेजेंट करेंगे? वेव साइन से. ठीक है, ये आपका फोटोन का है. ये फॉर गामा. और क्या है? ग्लूऑन है. ग्लूऑन के लिए क्या है रिप्रेजेंट करेंगे हम? सॉलिनॉइड टाइप का. ठीक है, ये आपका ग्लूऑन के लिए करेंगे. ठीक है, नेक्स्ट क्या है आपका? मेजॉन है. मेजॉन के लिए हम डैश डैश लाइन लेंगे. ठीक है, आपका फॉर मेजॉन 5 प्लस 5 0 5 माइनस. ठीक है, अब एक टर्म होता है वॉर्टेक्स. वॉर्टेक्स क्या होता है एनीबॉडी?
थर्ड वाला क्या बताया आपने?
हाँ, अगर थर्ड वाला मैंने बताया कि अगर मेजॉन एक्सचेंज पार्टिकल मेजॉन भी होता है ना, पाई मेजॉन.
यस सर.
तो वहां पे हम उसको रिप्रेजेंट करने के लिए क्या लेंगे? हम डैश डैश लाइन लेंगे. ओके, और ग्लूऑन के लिए हम क्या लेंगे? सॉलिनॉइड काइंड ऑफ लाइन. फॉर फोटोन के लिए वेव काइंड ऑफ लाइन. और फॉर पाई मेजॉन के लिए हम क्या लेंगे? डैश डैश लाइन लेंगे. ठीक है, अब एक टर्म होता है वॉर्टेक्स. वॉर्टेक्स क्या होता है बेसिकली? किसी को पता? VORTX. द पॉइंट
wedge and direction होगा more than
yes the point where three lines will meet. ओके, अब 3 लाइन का मीट होगा, बट वहां पे क्या होगा? 2 सॉलिड लाइन होंगे और एक आपका जो आपका
wavy line.
ओएवी लाइन होंगे. वेरी गुड, इट शुड बी ओएवी लाइन. और वॉर्टेक्स में क्या होगा? एक अगर पार्टिकल एंटर कर रहा है तो दूसरा क्या होगा? आउटगोइंग होगा.
Leave कर.
हाँ, लीव करेगा. सपोज मान लो एक आ रहा है तो ये एंटरिंग का है. अगर पार्टिकल है तो एंटरिंग का है. अगर एंटी पार्टिकल है तो लिविंग का साइन है. तो ये अगर वॉर्टेक्स है तो फिर क्या होगा? एक पार्टिकल लीव करेगा, है ना, और एक आपका वही भी रहेगा. मतलब 3 लाइन रहेंगे, 2 सॉलिड रहेंगे और एक का आपका वही भी लाइन रहेंगे. और वॉर्टेक्स में क्या होगा? एक अगर एंटरिंग लाइन है, सेकंड सॉलिड लाइन शुड बी लिविंग. ओके,
Yes sir.
डिड यू गेट व्हाट आई एम सेइंग? एवरीबॉडी, एनी डाउट? डाउट हो तो बताओ, क्योंकि आगे काम में आने वाले हैं आपका.
सर एक बार रिपीट कर दीजिए.
हाँ, पहले मैं बोल रहा हूँ कोई भी इंटरेक्शन को आप 2 एक्सिस के थ्रू डिस्क्राइब कर सकते हो. तो फीनमैन डायग्राम बेसिकली क्या करते हैं? कोई भी इंटरेक्शन को डिस्क्राइब करने के लिए है. सिंपलेस्ट वे है. तो उसने क्या किया? 2 एक्सिस लिया, एक आपका टाइम एक्सिस और एक आपका स्पेस एक्सिस. टाइम एक्सिस आपका कोई भी लिख सकते हो आप. यू कैन टेक इट वर्टिकल ऑन और हॉरिजॉन्टल ऑन. आई विल टेक ओनली हॉरिजॉन्टल ऑन, but it is not fixed. You can take any one. Okay, and for describing the particle you should have arrow, and that arrow should be in forward direction. Forward direction means it will increase with time. मतलब forward means क्या है? टाइम इंक्रीज होगा. जहाँ पे मैं अभी आऊंगा. और for anti particle or anti particle that should be decreasing with time. I mean with time it should be in back direction. With time it should be in back direction. Okay, and for any interaction you will have on vortex. Vortex means the point where 3 line will meet, and among 3 line 2 should be solid line, 1 should be wavy line. And for any vortex, if one particle is entering, another should be leaving. Why? Anybody? Why? Anybody? Open question. Why that one particle is entering, another should be leaving? Anybody? Any guess?
Mass
Or
conservation.
in annihilate, sir.
Yes,
Conservation
very
of
good.
matrix.
For the conservation laws, right? For the conservation of charge, then lepton number, baryon number, etc. Okay. Now we'll come to diagram. Then it will be very clear. So molar scattering. Anybody? Anybody have learned molar scattering? Molar scattering. Anybody? Anybody learn about molar scattering?
No, sir.
Okay, it's a good point that you will learn here, because in MSc nobody used to teach. So molar scattering basically क्या होता है? Alok, you have idea?
Sir, electron interaction.
Electron interaction, right?
Yes, sir.
Very good.
Scattering.
So electron plus electron interaction. This is known as molar scattering. So one electron is interacting with the other, then leaving two electron. Now we'll describe it through Feynman diagram. So if you draw it, this is your time axis. Okay, this is your space axis. Okay, so suppose let us take one electron. Suppose this electron is entering. So see, this is the representation before interaction. This is before interaction. So I'm taking this electron. This electron is like a solid line, and it is increasing with time. You see, time is increasing at every moment. You can check it through arrow line. So at every instant, time is increasing. Then another electron will be like this electron. Since these both are particle, so for any instant the time will be increasing. From here to here you can see that time is increasing. Then what will happen? What will happen? One electron will emit a gamma, but we don't know which electron will emit. Anyone can emit, right? Let us assume this electron come here and it emits one gamma, but it is not necessary that it will emit. For the sake of time, let us assume that this electron emit here, that one electron, and it leave as electron. So it will have less energy, right? Anybody? Have you agreed?
Yes,
So
sir.
if it emit on electron gamma, then it will have less energy. So this gamma photon will be absorbed by this electron, and it will live like that. किसी को कोई डाउट यहाँ पे हो तो बताइए. And you can see this is the vortex. Whatever I was saying, this is the vortex. So at this vortex, your charge, sorry, lepton number, baryon number, everything will be conserved. Any doubt? So you see, for particle I have taken forward direction. Forward means at every instant you can check time is increasing, because this is your time axis. Any doubt? और समझ में आया तो बोलिए जरा. समझ में आया? Everybody?
इस प्रोसेस में बस एक गामा फोटोन चेंज हो रहा है.
Can you please write that message, because the voice is not clear? Can you please text? Or anybody, Alok, whatever he is saying, can you please tell me?
Not audible, sir.
Okay. Yes, yes. Only here in this process, gamma is exchanging. You are correct. You are correct.
सर सर यहाँ पर कोई वेलोसिटी का कोई रोल है? वेलोसिटी इंक्रीज कर.
I don't think so.
Okay. सर बिकॉज स्पेस टाइम का जो स्लोप है, फर्स्ट वाला जो इलेक्ट्रॉन है उसके लिए
Yes, 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 yes. That's a deep question. This is, you are representing a space, and it is in on dimension, right? But space is not on dimension, right? So that's a very deep question. So not on dimension, you are representing this in on dimension. So it's very abstract. You learn in research. Okay, it's a very, very deep question. Very deep question. So you are representing this space only in on direction, but space is in three dimension, right? So very difficult to judge like that.
Yes, yes.
Another scattering, Bauer scattering. Everybody knows Bauer scattering.
Sir,
Yes.
sir, why we have uh, draw this diagram in 4-dimensional space?
Sorry.
So why we have draw this diagram in 4-dimensional space in F4?
Yeah, actually, if you see, many scattering and interaction process are there, and if you see that inner description in field theory, definitely we will take that field theory. You will learn it's a very abstract. It's very difficult to visualize or describe that phenomena. That's why Feynman sorted out that problem, and it describe every interaction he can describe by this diagram, by taking these two axes. Okay, you learn this thing. I'm just giving that flavor. You learn deeply when you will go for quantum field theory, or we will take that specialization course. Okay. It's very difficult to understand in every interaction. It's very difficult. Many things you can find by this interaction process, scattering amplitude, blah blah blah. Many things. Bhava scattering. Anybody knows Bhava scattering? Anybody? Bhava scattering. Any idea? Anybody? So if you see that Bhava scattering, sorry. So one electron is interacting with one positron, and it will give electron positron. Okay. So if you see the diagram of this process, this is your time axis, this is your space axis. Okay. So one electron is entering like that. Now what about that positron? Anybody? So electron is
In the downward facing.
it should be, it look like it is leaving, but it is actually entering. I told na, for antiparticle that direction should be in backward direction. So for positive, this is for electron, this is for positron. It is entering, but look like it is leaving. Okay. Now what will happen? What will happen? There will be emission of one photon, but I am not giving direction for photon because I don't know which one will emit and which one will take. Okay. And it will be like that. So see, it is like entering, but it is actually leaving. Okay. And for this, it will be like that. So you see, I am not giving, this is the gamma, this is the exchange particle. So I am not giving any direction for gamma because I don't know which one will emit and which one will take. Okay. Is it correct, everybody?
Yes.
किसी को कोई डाउट, किसी को इसमें, किसी को कोई डाउट?
सर आप एक बार रिपीट कर दीजिए डेटा.
Yes, yes,
yes.
Shall I repeat?
Yes.
Yes. One electron is entering. Okay, this is before interaction. Okay. This positron is entering actually. Its arrow I told na, for antiparticle representation it will be in backward. So you see, time is along this forward axis, so it should be in backward. Actually, the arrow is showing it is leaving, but it is actually entering before interaction. Then after, what will happen? Any one of this particle will emit on photon, and other will emit or will absorb that photon, and they will leave like that. So this is like entering, but it is actually leaving, and this electron will leave like that after interaction. So there will be exchange of gamma. photon. Anybody? Any idea? Sorry, any problem? Any problem?
So they don't really collide head on.
Hadron?
I mean, there is a head-on collision or not between electron and positron?
Yeah, they may be head-on collision, but emission is showing like that. Maybe.
No, sir, they are antiparticles. ना annihilation हो जाएगा इससे पूछा.
Yes. You are correct. You are correct.
Collision नहीं हो रहा है फिर.
Collision, yes, collision हो सकता है ना. कोई problem है इसमें? Collision हो सकता है.
नहीं सर, एंटीपार्टिकल है ना, तो annihilation हो जाएगा collision में.
हाँ, that's a, yeah, you are correct. If there is a collision, there is no collision here. If there is a collision, then there's definitely gamma, right? So here there will be no collision. That's why it says scattering, right? That's why it says scattering. There should not be any head-on collision here. You are correct. Yes. So I think time over हो चुका है.
सर क्लास कैंसिल हो गया, नेक्स्ट आप पढ़ा सकते हैं.
क्लास कैंसिल हो गया?
यस सर.
So I'm taking 2 more problems. तो ये एक्चुअली CSIR रिलेटेड नहीं है, जिसका इंटरेस्ट है ना, इस आगे काम करने के लिए डेफिनेटली इट विल बी हेल्पफुल. नेक्स्ट क्या है आपका? बीटा डीके. बीटा डीके में क्या होता है बताइए जरा. एनीवन? व्हाट अबाउट बीटा डीके, बीटा माइनस डीके? हाउ डू यूज्ड टू हैपन?
न्यूट्रॉन कन्वर्ट्स इनटू प्रोटॉन.
Okay, so neutron convert into proton, right? Then we'll have electron, neutrino, right?
Antineutron.
So we'll represent the diagram also here. This is your space, your time. Yes. So suppose on neutron is coming. Okay. So it will limit W minus, right? This will be your proton. So neutron is coming and it will leave on W boson and it will emit proton also. Then what will happen? Immediately that W will decay to what particle?
Electron and antineutron.
So for electron it will be in forward direction, but for anti-neutrino it will be in backward direction. So neutron emitting on W boson and leaving proton. So it is also emitting proton, and W boson what will happen? It will immediately decays to electron minus and its associated neutrino. Okay.
So
Yes.
neutrino direction opposite.
हाँ, opposite backward direction हो जाए ना, antiparticle ना, backward direction हो जाएगा. ठीक है? Okay.
ये diagram आगे से थोड़ा अजीब.
अजीब? Why it's अजीब? You are looking at dash and that's why you are saying अजीब or any other. So neutron decays to proton, right? So first what will happen? Neutron decays to proton by exchange by emission of W boson. Then W immediately decays to electron and its associated neutrino. That's it. So अलग-अलग
सर
yes.
सर अपना कांटेक्ट नंबर शेयर कर दीजिएगा.
Quantum number? Okay. You have my contact number, right?
I have, sir. Puneet is asking, sir.
Okay. I'll share. Okay. You can give him also, no problem.
Okay, sir.
You can give. Okay. Another is that pair annihilation. इसमें क्या होता है? Electron minus plus electron plus
Positive.
2 gamma, right? 2 gamma, right?
Yes, sir.
Okay. Can you represent it? Please, can you please help me? Help me, anybody? is your time axis. This is your space axis. So what will happen? One electron will come. Okay. So it will emit one photon. Okay. So there is emission of one photon. This is your vortex. Then what will happen? Positron is entering like this. This is your positron. It looks like it is leaving before interaction, but actually it is entering. So after this and this will combine and it will emit one photon. Okay. Any doubt here? So what is happening? One electron is emitting one photon and it will release one electron, and that electron and that positron will combine and it will emit another photon.
So why the electron is emitting photon before any interaction?
Yes. So when it will emit a photon, anybody? Alok?
सर एनर्जी लूज करने का और कोई तरीका नहीं, उसके पास वही इंटरेक्ट.
Yes. We lose that energy. Okay. So I think I should stop here. Okay. So
Sir, photons are emitted here must be before at the time of interaction, right?
sorry,
At the time of interaction, they must be
before the type.
photon must be emitted. Yeah.
No, that is not always. Whatever he is saying, Alok, he is saying correct.
I did not understand, sir.
He is saying that that photon should be emit at the time of interaction. That time is very small. You cannot check, right? It's a very small. This thing is happening within a very small time. Is not it, Alok?
Yes, yes, sir.
Not it. So basic description of Feynman diagram is like that. One electron will come, it will emit one photon, and there will be another electron. This electron will combine with this positron and it will emit one photon. Okay. So I should stop here. So that there I'll discuss about that string theory little bit in doubt class. Okay. And
So what is your interest, your area of research actually?
actually my area of research is condensed matter physics and basically solar cell, thermoelectric material like that. Okay. So basically
Yes,
I work on lead free double layered perovskite based solar cell. Okay.
yes.
Okay. So I'm leaving here also. Okay.
Okay.
Thank you, sir.
Okay. Most welcome. Bye all. Huh?
Thank you, sir.
Most welcome. Bye all.
Thank you.
Thank you, sir.